I'm Mr. Dave, and this is
Haley.
Haley, the world's greatest assistant. She's helping me out today with our All Atomic series, and she's going to help me do a little kind of game thing that you guys can play at home that involves some math, some science, some probability and statistics, and other words like that she understands that I don't. Okay, so we're going to talk about the half-life of an isotope. Now, an isotope is an atom that the protons and neutrons are out of balance. And so it's trying to reach that balance, it's trying to reach a stable point, and it doesn't just go away, it will transmute into something else, okay? Now, the half-life is, when you say the half-life of this isotope is however many years, that would mean how long it takes for half of those atoms to decay. Okay. Now remember, when they decay, there's no creation or destruction of energy or mass, and so it will, instead of just going away, it'll transmute into another isotope. Cool? Yep. Yeah. Sound good so far?
Sounds good so far.
All right. If it sounds good so far, she says it's good. It's good. So we're going to show you guys how to do a fun thing that has some stuff for the little guys and for the older guys. And we're going to show you a half-life kind of, like I said, kind of game demonstration. And we're going to use some Scrabble tiles. Okay. So I'm going to set this right over here. We have, in here, we have our Scrabble tiles. Now, a game of Scrabble comes with 100 tiles. So if you look on our little graph over here, you'll see that it goes 10, 20, 30, 40, 50, 60, 70, 80, 90, 98. Okay? Now, 98 is because we have two of these that are blank on both sides, right? So we would end up with it in a poor spot at the end because these ones would never undergo decay. Exactly. Okay, so if you want to come up here with me, what we're going to do is we're going to show how that half-life works on our graph with these Scrabble tiles. Now, we're going to roll them out. We're going to put them out on the table here. And the ones that are face up
yes,
are going to be decay.
Letter up.
Okay. By face up, yeah, we mean the letter. Yeah. The ones that are letter up are going to be our ones that have decayed. The ones that are letter down are going to be our ones that remain.
Which is why those blank ones will give you a hard time.
Yeah, because we would roll forever. Yeah, because you'd have blank ones every single time. Yeah. Haley noticed that. Yeah, and then really, yeah, she's like, Dad, we've rolled 100,000 times.
Okay, yeah, not that many times, but
a lot. Yeah. All right, so we're going to roll these out. Now, I have an extra little thing in here, the letter Z. Okay? Now, the Z, there's only one Z in a Scrabble game. Now, I put a little dot on the Z so we could find it a little bit easier. But an extra thing you can do with a little bit older guys, or even with the younger guys, is try and predict when any one tile is going to flip. And in this case, it's going to be our Z. Yep. So, when do you think our Z tile will flip? Or decay?
2.
2? All right, try 2. So, what her prediction is that on our second roll, our Z tile is going to decay. And that's trying to predict when at any time in a half-life, one of those atoms, or one of those isotopes, which is that out-of-balance atom, can decay. Okay? So come on up. You'll help me out. Are you ready?
I'm ready.
You ready?
Shake them up.
Shake them up. Shake them up. There you go. Spread them out. Ooh, that was nice. All right. So our ones with the letters up, we're going to know have decayed. Okay? And so showing the half-life is showing about the lifespan of some of these atoms and other ones that are going to stick around a little bit. Okay, so we have our face down tiles. These ones are going to stay. And then we're going to count the ones that are going to have decayed. Okay, now first, did our Z decay yet?
I have not seen it.
Okay, so our Z is still in place. Okay, so I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, which is half of 98. So now probabilities, statistics, things like that, it's pretty close. So if we had our 48, that'd be right underneath that 50. Now, one more tile and we would have had like exactly half, right?
We had 49.
We had 40. We did? Oh, I thought I said 48. Oh, cool. Yeah, so we had exactly half. I knew that the whole time. That's why she's here. Okay. Wow. Okay. That's why I do science stuff. She does the math stuff. All right, so here we go. Let's see. We'll roll them out. Yep. I can count. I can. All right, so our face down tiles are the ones that are going to remain. And our face-up tiles are the ones that decay. Now, did our Z tile decay yet?
Still no Z. So.
It is still not decayed. I flipped that one over. So let's see how many decay this time. I'm going to start counting while you're separating them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? Now, that's not exactly half. Because again, in that half-life, you're going to have ones that decay and ones that don't, but we're going to see how that turns into our nice little curve of a half-life in just a minute. Okay? Now, do we have our Z yet?
Still no Z.
Still no Z. Okay, so these ones that are up, I'm going to count these ones here that have flipped. Our Z has still not shown up, so I'm hoping it's still in there and it didn't fall on the floor. Yeah, okay, so 2, 4, 6, 7. So we got 7, okay? All right, here we go. I still don't have a Z. All right. So now we have 3, okay? I'm hoping that that Z didn't fall on the floor. All right, so our Z is possibly making it down to these last 3, meaning trying to predict when any one atom is going to decay is really impossible. There's that whole there's a Schrodinger's cat demonstration that is involved this right here with that letter Z. Is that cat alive? Is that cat dead? Yeah, anyway. All right. My cat is actually hiding around the corner. You might see him in the back of this video. All right, so here we go. All right, let's see if that Z is still in there. We have 3 left. And
Z!
Oh, there is our Z. High five. We got our Z. Our Z is finally shown. 1 remaining. Okay, so on our graph there, we are down to 1. And it has decayed.
Cool.
There you go. Okay, so go ahead and graph that out. Start at that 98. And we can see that the half-life that is the half of those atoms, the time that half of those atoms take to decay, we can see, even with the weird... You might have just heard my cat on the video. He heard us talking about him. All right. Yeah, so that's Ray Cat. Yeah, anyway. Hi, Ray. So you can see that graph, even though our probability is huge, the graph kind of gives us that nice little curve anyway. And that's showing how they can predict the half-life of one of these isotopes. Okay? Remember, an isotope is an atom that is out of balance. Okay? Different protons and neutrons. This little demonstration, this little game here, we found it on our website, the nuclearmuseum.org. There's a link there to Nuclear Science Week. Okay. Now, Nuclear Science Week has got some activities that you guys can do if you're interested in nuclear, and they're like, some of them are like this one here, that they incorporate other concepts like math, probability. It has a way of doing this same demonstration for the little guys, and a way of doing it for people way smarter than me like Haley. So remember to check out Nuclear Science Week on our nuclearmuseum.org's website. It's got some fun activities that you guys can do when you're at home. All right. Remember to like, subscribe, share, and wash your hands.